All right. Good day again. So we're here again to tackle statistics using Microsoft Excel. Okay, to simplify. Okay, so our past activities it tackles about the estimating the population mean. Okay. In this example here, we will be tackling more in estimating the population standard deviation. Okay. What's the estimated range of standard deviation? Okay, so we have here a sample from the book. Okay, and we just have to simplify this one. And as much as possible, I will explain it in a simplest way. Okay, so we'll get straight to the topic. Okay, on how to compute using Excel, and then later I will explain here what is the meaning of this uh, formulas here. Okay. So we have the existing data. Okay, so these are the weight, and we have a mean 1049, 144 for the total sample. Okay, this is small n. Okay, and this is just a sample, not a population. And the standard deviation is 376.5. Okay, what we need here is the standard deviation. So I put it in here, standard deviation. Basically, the standard deviation, the variance of that, or the s raised to the 2 power raised to the second 2 power is 141. Okay, the computation of that is this one. Okay, see that? D6 and then I raise it to the second power. Okay, so you might ask, what are these one here? Okay, so these are the chi-square value. Okay, so what are chi-square value? We will just have to look at that here. Okay, so the chi-square value, we have a value of um, so this is 90, since this is 95%, okay, 95% confidence level, okay, just have to put here 95% confidence level for these two, okay. We will be needing these two for the upper and lower bound, lower limit, okay. So here, I just got this from the book, okay. This is a table, okay. So this is the table for the degrees of freedom. The degrees of freedom is this one. Okay, so this is one here is the degrees of freedom. And we wanted to know the 95% level of confidence. So the 95% level of confidence for the lower limit, okay, since this is 144, okay, minus 1, okay, so this 143, okay, so it has always n minus 1, okay. That's the rule of the chi-square. Okay, it's 143. So the nearest number for 143 is 150. Okay, so we'll look for that x chi-square 0.025. Okay, so it's 185.8. Okay, 185.8. Okay, 185.8. All right. This is 185.8. Okay, so the upper limit, I mean, is x 0.975. Okay, so if we try to look at that, okay, it's x 0.975. Okay, this one here, degrees of freedom x 0.975 is 117.985. Okay, so 150 again. Okay, here. So we put it in here. Okay. So these are the confidence level for the upper and the lower and the upper limit of the chi-square. Okay. And our n is 144. Okay. And to look for, and whenever we wanted to look that for the degrees of freedom, we just had to less this one by 1. So 143, and we look for the nearest um, number here for 143. So the nearest there is 150. Okay. So now let's compute for estimating the variance. Okay. Variance in here. Okay. So to estimate the variance, we need to um, sample minus 1 multiplied by the variance. Okay. Over this one here, 185. This is the lower limit. Okay. 109 to, okay. So by the way, this O2 here signifies the this one. Where is the logo? This is actually a standard deviation. Okay, this is a Greek word for this one. Okay, like this one. Okay, okay. We just um, we're just following this computation here, and later we will explain that. Okay, so this O2 is this one. Okay, and we also compute for this one. Okay, uh, n minus 1, so 144 minus 1 multiplied by variance and then over another 17. Okay, what happens over this one? Uh-huh. Okay, so just have to, okay, so now we have so the estimated variance is 109 to 171.35. Okay, so now that we have the variance, we'll compute for, by the way, this is already been computed. Okay, so the computation for that is this one. This is square root again, QRT, and this one. Okay, the same here. Okay, so this value here, these values here are the standard true standard deviation at 95% level. Okay, so I um just we just copied it. We just This is our guidance for this confidence interval for the standard deviation or variance. Okay, so standard deviation is just a square root of the variance. Okay, that's basic. Okay, so since we have already the confidence interval for the true standard deviation of the population. Okay, so um, now we will conclude. Okay, so for example, your threshold. Okay, your threshold is this threshold is at least at least 400. Okay, you will have at least 400. Then depending on your study. Okay, so since this is fish here, so let's sample. Let's say your threshold is 400. then you found out that the weight of the fish in the pond is 400, then, and according to the study, a weight of 400 is healthy, then no need for further investigation. Okay, so your study will stop with this single sample. But if your threshold is 500 and you have a reference of a healthy fish, a 500, let's say 500 milligrams of, 500 kilograms of weight, let's say for example, a 500 milligrams, okay, then you can conclude that you can easily say you can easily have a hypothesis or a conclusion that you need a further study. Okay, so this is the one of the purpose of finding out the standard deviation or the variance of a study. Okay, so now let's get to the explanation of these formulas here. So I just copied like this one. So n here, n is this one. Okay, this is sample. Okay, minus one has already been given there, and this is variance S2. Okay, so this is the variance. Okay, and this one chi-square alpha over 2. This is pronounced as chi-square alpha over 2. Um, this is this one. Okay, alpha over 2. Okay, when you say alpha over 2, it's a zero point 0.5 divided by 2. So it's point alpha, uh, so it's point zero 0.025. Okay, and this one also 1 minus alpha over 2. Okay, so since we just lessen this one, zero point zero 0.05, we already have the alpha, like this one. You have, it's like 1 minus zero point zero 0.025. Okay, so you have a 9.75 shown here. Okay, okay. So this is what it means by alpha of 0.975 and alpha chi-square of 0.025, right? Okay, so it's clear now. I hope so. So these are the rules on using this chi-square. Okay, so I already have explained it. This one here. So these were the conditions. Okay, so a random sample is selected from the target population. So a random sample from the target population. Okay, and the population with a representative frequency of that is approximately normal. Okay, so like this one. So this is a whole normal distribution. So before doing this one here, estimating the population standard deviation or variance. Okay, um, you should check the histogram of your sample, right? Okay, so I think I already have explained it all. Okay, so I'll see you again, and I hope you learned something from me today. Okay, thank you.